So in an experimental design, the researcher is actively trying to influence the result. He's directly controlling or making changes to a variable and looking to see what impact that has on other variables. In this kind of study, like our observational studies, it comes in a wide variety of types. So kind of the most basic is what's called a completely randomized design. In this scenario, every member of the population is treated identically, right? They're indistinguishable, like the blocks on the pattern here. Everyone has the exact same probability of being selected and included in the sample. Now, going down to slightly finer level of detail, we have something called a randomized block design. In this situation, you know that there are certain important characteristics in your population. For example, if you're studying fruit trees, you don't want to risk having a population that only has orange trees in it, because you risk finding yourself in a situation where you accidentally get a result that only applies to oranges. So when you know that your population breaks down into categories that are somehow possibly relevant to your study, those categories become the blocks. You want to make sure that you're sampling from all of the relevant blocks when you're forming your sample. And you can kind of connect this back to the stratified samples that we talked about several lectures back. Right? In a stratified sample, the population somehow naturally breaks up into categories, like the grades in high school. And you take advantage of that, right, to get information relevant to all of the different categories. This is kind of the same thing, only there's a little bit more of a sense of urgency to it. We really, in this case, need to make sure we're sampling from those different blocks, because they could potentially have significantly different results that could be important to our final results. A third type of study is what's called a matched pairs design. And this kind of study, the participants kind of come in natural pairs. Right? For example, you might have husbands and wives. Right? When you're doing your study, you're getting pairs of spouses because you want to contrast their responses with each other. Right? Another example of this would involve using twins. There's a classic example of this is the astronaut experiment done with two NASA astronauts, Scott and Mark Kelly. The two of them were twins, right? So NASA sent one of them up into space in the International Space Station. The other one stayed on the ground. So when the space astronaut came back, they kind of had a baseline. They had something to contrast him against, so they could see what effects being in space for that time had on his physiology. And having an identical twin to compare against let them eliminate a lot of possible factors that could have caused changes they were observing from a genetic basis, right? Because the twins obviously have the exact same genetic basis, they knew there couldn't possibly be any genetic explanations for something that they didn't see in both astronauts. So this brings us to the end of our discussion of different types of studies. In the next section, we're going to go on and we're going to talk a little more about bias. Right? I've hinted at several different kinds of bias here. And in the next couple of lectures, we're going to look at that in more detail.